Hello, hello, hello. We are doing section 24.2, so we're continuing lesson 24, which is a study of the Pythagorean Theorem and how we can apply it. So what we're going to go with today, we're going to start with here, we've learned that the Pythagorean Theorem is a squared plus b squared equals c squared, and that's for right triangles only. And now we can use this to model it in real world problems and also solve the problems with this Pythagorean Theorem. So that's kind of our learning target for today. A couple of things that you have to know in order to be successful today is that the Pythagorean theorem only works for right triangles. But guess what? There's right triangles everywhere in the world, or you can make them out of things in the world. A squared plus b squared equals c squared is the Pythagorean theorem, but know that c is the hypotenuse, that's the longest side. And then the third thing is we're going to need to be able to create models that involve right triangles. So let's get into it right away. These notes are on page 212 in your notes book. That's where they start, 212 to 213, I believe it is. All right, so I'd like to see you follow along, take some notes. Really try this problem at the beginning on your own first, if you can. It says the transmitter for John's thermometer has to be less than 50 feet from the receiver. You probably know if you have Wi-Fi at your house that the closer you are to the modem, the better signal you have for the Wi-Fi. If you're too far away, it doesn't work. So in this case, it's saying a thermometer has to be. It works the same way for a digital thermometer. It has to be within 50 feet of the receiver. So he places the transmitter T and the receiver R in locations shown on the map. So here's the receiver, here's the transmitter. We're trying to figure out if those are close enough to each other. It says, are the two components less than 50 feet apart? And all that we know is the dimensions of the walls. Okay, because it's hard to measure through other walls. So we can go the length of the walls, but it's hard to go through. So if you want to figure out the distance from T to R, we want to know that straight distance. Now here's the thing. Once you did that, if you connect these dots, guess what's made? It's a right triangle. Because the walls are as close to 90 degrees as possible when they're connected there. So right triangles, we can use the Pythagorean theorem. So here's one way to model it. If you didn't do it this way already, and you kind of just had to draw the line, you can see in your notes book there, it's drawn where that line is going across from T to R. Now here's the thing. That makes a right triangle, and that missing side length from the transmitter to the receiver, that is the side that's across from the right angle. That means that is the hypotenuse. Which is always the C. Okay, the other two don't really matter. You can switch them around, but in general, I would go smallest to largest. So A, B, and C. So now, if we're using our Pythagorean theorem to solve it, you can set it up like this. A squared plus b squared equals c squared. We would have 24 squared plus 32 squared equals c squared. And we're going to work through that now on the next page with how to solve it. So here's some of the questions on there. It says, explain how you know that the equation 24 squared plus 32 squared equals c squared represents this situation. And I'd like you to think about that, what we just talked about. Okay, a couple things that are important. We have a right triangle. That's the first thing. We proved that for right triangles this works. We did that in last lesson. That's the first thing. We also have the lengths of the two legs. The triangle, and are trying to find the hypotenuse. That is our C. Okay, we'll leave it at that. Because when you plug it in, it's just a formula. You plug in for a formula and you solve. So number 3 says use a calculator to solve for C to the nearest foot and show your work. So let's actually take that. I've got a calculator here next to me. I'm going to grab it because I don't know what 24 squared is or 32 squared, but in order to solve this, it's good to know what those are. So if I have 24 squared plus 32 squared equals c squared, I want to first figure out what 24 and 32 squared are. So 24 squared, or 24 times 24, I get 576. 32 squared, which is 32 times 32, is 1024. 1024. And those are added together, so let's add them together right away. So 1024 plus 576, I get 1600, and that should equal c squared. Now, think about solving equations. We have the c squared by itself, but we don't have the c by itself, and our last step is to do the square root. Okay, so that'll get us c all by itself, and the square root of 1600, you might want to use a calculator for that. I know the square root of 16 is 4, so I'm guessing it's going to be 40. Square root of 1600 is 40 indeed. That means the length to the nearest foot is 40 feet. And that's the work that was shown. So question 4, are the transmitter and receiver close enough to work? And how do you know? Absolutely. They are less than 50 feet apart. Because they're 40 feet apart. All right, number 5. Consider the Pythagorean triples listed in the introduction. So in our last video, talked a little bit about Pythagorean triples. What set of triples does this problem use? So it would be 24, 32, and 40. Together, they're all whole numbers, and they all work in the Pythagorean theorem together, which means they're a Pythagorean triple. So if you knew that was a Pythagorean triple, you didn't have to do all the work to solve it. So that's the second question here. How could you use solve the problem using a multiple of Pythagorean triples instead of the squares of square roots? So if you, let's just see what they all go into. Maybe you know that one very common Pythagorean triple is 3, 4, 5. Very common. Okay. I know if I multiply all those by 8, I get 24. 4 times 8 is 32, which are the two side lengths that we had. So 5 times 8 is 40. So that's one way you could do it instead. Okay, if you use multiples of Pythagorean triples like that. All right, finally, I'd like you to try to answer this last question on your own. It says, number 6, it says, use what you've learned about the Pythagorean theorem to solve the problem below. Show your work on a separate sheet of paper, or you can just show it on the page you have there. There's enough space. And if you need to explain. But what we're trying to find here, it says explain how you might use the Pythagorean triple. Oh, so explain how you might use the Pythagorean theorem to find the height of this triangle. And the height would be this side right here, this AB. All right. So I'm going to ask you to pause the video and try using the Pythagorean theorem to solve for A. And then you can unpause it. You can check how I did it. All right. All right, hopefully you tried it. Hopefully you recognize that, well, I have a right angle here. So then next to it has to also be right angle because those two have to add up to 180 together, which means I will highlight the right angle that we have two side lengths for. We have 15 and we have 17, and we are missing the height. Now looking at that, the height is definitely the smallest side length. So if I'm trying to use a squared plus b squared equals c squared, which is the Pythagorean theorem for right triangles, the missing side length is going to have to be the A. It's the smallest side. This is the B, and then the one that is across from that right angle is always the hypotenuse, which is C. So if I plug them in, I am missing A squared, so I have A squared still there, plus 15 squared equals 17 squared. And I know some Pythagorean triples, and if you know this one, I think this is going to be a Pythagorean triple. I think it's going to be a whole number. But let's check it out. Let's try 15 squared. 15 squared, 15 times 15, 225. So a squared plus 225 equals 17 squared. Check that on a calculator. 17 times 17. I got 289. All right. And then finally, I can solve for a squared. I'm not going to add the 225 and the 289 together because they're not on the same side of the equal sign. But I can subtract 225 from this side to get a squared by itself. And then I have to subtract it from this side as well. And I bring that down. I have a 4, I have a 6, and that's it, 64. So a squared equals 64, but that doesn't tell us what a is, because a is definitely not 64. That's got to be smaller than the other two sides. So the last step is to take the square root to solve for a. That'll give us a by itself, and the square root of 64, hopefully you know, is 8. Meaning our height is 8. It doesn't say what it is, so we're just going to say 8 units. So that's how you can show it, and it does ask you to explain that in words there, so make sure you're able to explain that problem there. So there is some application of the Pythagorean theorem and how we can create right triangles and then be able to solve for missing parts using the Pythagorean theorem. And that's section 24.2 for you. We'll see you next time for section 3 of this lesson. Have a great rest of your day, everyone.